Good afternoon, ladies and gents, and boys and girls. Today we are going to look at IGCSE Mathematics, and we will focus on the February-March 2015 paper 42. Okay, so let's jump in and start directly with it. Jacob builds a house and sells it for 450,000 Rand. He pays a tax of 1.5% of the selling price of a house. Show that he pays 6,750 in tax. Okay, how would we do it? We just know that the percentage of a number equals another number, and we have 1.5% of 450,000, and if I tap that into my calculator, I get 6750, and that's exactly what they wanted. Okay, let's look at the second question there. Move my paper up slightly. In 6,750 is 12.5% more than the tax Jacob paid on the first house he built. Calculate the tax Jacob paid on the first house that he built. So I like to start off with a little diagram. So this is the first house, and we can call it X. Then he have to pay some extra, and that is 12.5%. So the tax that he paid originally was 100%. Okay, now if we calculate that all together, that would give us 112.5%, and that is equal to the amount that we've got now. So we have 112.5% of X would give me 6750, and if I do the calculations, X would be 6,000. Okay, good. Let's move on to the next one. The house is built on a rectangular plot of land, 21 meters by 17 meters. Both correct to the nearest meter. Calculate the upper bound of an area. Okay, so we have a plot of land, and that is 21 meters, that is 17 meters. We want to find the area, so area we know is length times width. What is the upper bound of 21.5? That would give me 21, it would be 21.5, and the upper bound of 17 meters would be 17.5. I do the calculation to receive, there we go, 376.25 meters squared, and that would be my answer. 376.25 meters squared. Okay, let's move on to the next question. Okay, on a plan of a house, the area of a kitchen is 5.6 centimeters squared. The scale of a plan is 1 to 200. Calculate the actual area the kitchen has. So I've got a map, and I have an actual area. Okay, so my map there is 5.6, and I want to find this area. Okay, so there I have 1 and 200. So that would give me a ratio of 1 to 200 equals 5.6 over x, but we know that that must be squared, the square root of it. So I can actually find x. Okay, the square root of x first, that would be 200 times the square root of 5.6, and then if I do the calculation, I find x, and they want it in terms of meter. So I've got to be careful here, because these calculations, or these numbers in terms of centimeters squared, so that x that I have found, let me write it here, it would be 224 centimeters squared. If I want to change it to meter squared, I've got to multiply it with 1 meter over 100 centimeters and another one, and that would give me a result of 22.4 meters squared. Okay, good. Let's move on to the next question. Just want to turn the page. Okay. The house was built using a cuboid blocks, each measuring 12 by 16 by 27 meters. So I've got a little cuboid. And just quickly draw a little sketch there. 12, say 27 and 12 and 16. How do I find the volume there? Well, we know that volume is length times width times height. I'm just going to write it down. And then fill in the values. That would give me 5184 centimeters cubed. And yeah, 5184. I'm just checking that they do want the answer in centimeters cubed. Okay, good. JF changed 12,000 euros, dollars into euros to buy a land in another country. The exchange rate was €1 is $1.33. Calculate the number of euros JF received. Give your answer correct to the nearest euro. So we only want whole numbers. So 12,000 times euros, dollars 1.33. I plug that into my calculator and I get 9022.56, but I only want it to the nearest euro, so that would give me 9023 euros. So 9023 euros. Good, so we're done with question 1. Let's move on to question 2. Here I have a Venn diagram. Okay, when we have Venn diagrams, sorry for the cough, let's have a look at all the relative information that they've given us. So this is all the numbers 1 to 10, so you can write it out for yourself. 8, 9, and 10. And then the factors of, so x is where the a, set A is x, where x is a factor of 12, but it's got to fit into our universal set. So 1, 2, 3, 4, and 6 are all factors of 12. That will be part of my universal set. It's an odd number, so 1, 3, 5, 7, and 9. It's an odd number, but does fit my universal set. And C is a prime number, so we have 2, 3, 5, and 7. Okay, now that we've worked out this little bit, we can actually fill it in our Venn diagram. Then 1 is in A and in B. 3 is in all 3 of them. Let's quickly have a look. 5 and 7 is in B and C. 2 is in A and C. Okay, now let's have a look. 4 is just an A and 6 is just an A. In B we have just a 9, and we've got all the C's already there. Then we haven't done a 8 or a 10, and that goes in there. Good. Now we can use look at the second question there. Use set notation to complete each statement. 6 is an element of A. A union B, intersection B, intersection C. That number is just the element 3. Okay. A naught would be an empty set. Okay, if I have A but I do not have A, I get an empty set. Find the number of B. Okay, B it's quite easy. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and that would be the number of elements in B would be 5. Okay. Now for the next question here, use the set notation to complete the statement. U and V would be a proper subset of Z. It would be a proper subset of Z. Okay. And then shade X intersection z and the union of y not. So it can't be z and it can't be x, y and z. It was union of those, but it's not. And it's x intersection with that. So what I reckon it is this bit. Okay, and because it is not in parentheses, I would also shade the bit that's left. Okay, and that is my answer. Good, let's move on to the next question. Okay, it's the table of some of the values of this beautiful cubic function is given to us, and then we have to fill in those missing numbers. It is very easy to find those 3 marks. All you have to do is substitute that -2 into your equation using parentheses. So I will quickly write it there for you. So y equals, say, a substitute -2 in, plus 3 -2 squared, -2. I tap that into my calculator and I will find an answer. So my first answer there is 2. Then for -1, I got 0. For 0, I just have -2. And for 1, I have 2. Okay, and that will give you 3 whole marks. Good, so let's have a look at the next bit. On the grid, draw this graph for the interval -3 to 1. So we're only interested in -3 to 1. And actually, they've given us the complete grid, so it's going to be awesome. I had a chance to quickly do just the markings prior to what I've started on the YouTube, so it makes it a little bit faster. Then one smooth line. Don't worry about the artistic value. Just looking at one smooth line. Okay, that would give you 4 whole marks. Okay, good. So then they say by drawing a suitable line, solve x cubed plus 3x squared minus 2 equals a half, and bracket x plus 1, close your bracket. Okay, so we know that this is the graph that we've done on the grid. This is a straight line. If I solve here, I get a y-intercept of a half and an x-intercept of -1. Okay, so I'm going to draw this line using those 2 points. I've got my little straight edge here. So -1 is there and a half, and that would be the line passing through those 2 points. Let me quickly draw it as neat as I can. Okay, remember that on grids and on your sketches, use your pencil only. Don't use a pen. If you make an error, you can always correct it. Okay, now they've asked us what would be the suitable, what would be the intersection, or where would it be solved. I'm going to read down these x values. So that would be 2.5 and 1. So it's 1, 2, 3, 4, 5. So every 5 is there's 1, 2.6, 2.7, 2.9. I get 2.9. Do you also get 2.9 if I count that? So my x value here would be -2.9. Okay, that one is easy. It is just on the x-axis, it is -1. And let's quickly read this one off. I get 0.8. Okay, good. So it will differ from yours slightly, and they do give them a range of values that will be correct, except that one, it has to be -1. Okay. Okay, by drawing a suitable tangent, find the estimate of a gradient of the curve where x is -1.75. So negative 1.75, there's negative 2.5, negative 1.5. There we go. At that point, okay. So I'm going to draw a tangent there. A tangent is a line that just touches the curve at that one specific point. Okay, and let me see. I think that's about as nice a tangent that I can draw. Okay, now we've got to read down two points on that graph. I'm going just to take these 2 points. Maybe that one would also work quite nicely. Okay, let's quickly read it. That would be the point. I'll quickly read it down. It takes a little effort. 1, 2, 3, 2.3, negative 2.35, and we have a y value of 3 there, and this point over here, we have a y value of 0. That is awesome, because then I have less to think about. And let's see what the x value would be. That is 1 over there. 1, 2, 3. So 0.7, negative 0.7. Good. So let's use those two values and find the estimated mean. Okay. So the the estimated gradient. The estimated gradient is just because we are actually drawing those lines in. We are not doing calculus at the moment. We are looking at the graph and just drawing in a tangent to find the estimate gradient of a graph at that point. So m equals delta y over delta x. That is y2 minus y1 over x2 minus x1. That would give me y2, let's look at it at 3 minus 0, and my x value, negative 2.35 minus negative 0.7. Okay, it will be a negative gradient. I can use my calculator to quickly find the answer. Let me quickly tap it in here and then do it. 3 in my numerator, negative 2.35 plus 0.7. That would give me negative 20 over 11, an estimate of negative 1.8. Okay, negative 1.818, so negative 1.82, negative 1.82 is my estimated gradient of my tangent. Okay, good. So as you would have guessed, there would be a range of values that would be correct for that answer as well. Okay, so the next question that we're looking at is just factorization. We can recognize that 121 is actually 11 squared. So I have 11y squared minus m squared. I can factorize this. 11y minus, and a plus. This is the difference of two squares, m, and that would be my answer. 11y minus m and 11y plus m. Good. Now the next question, we have to also write this as a single fraction. I'm going to start off by multiplying on this side with x minus 1 over x minus 1. multiplying on that side with 3x minus 5 over 3x minus 5. So this is just a fancy one. It doesn't change the value of my equation, but it does give me one single denominator that we really want as a single fraction. Okay, so now we just have to distribute there, so that will give us 4x minus 4 plus, and if I do the distribution there, get 3x squared minus 5x plus 6x negative 10. Okay, still have to do a bit of work there. 3x minus 5, x minus 1, and if I do the simplification there, I get 3x squared plus 5x minus 14, and that would be the answer that I will write down here. Okay, I did check. This is the discriminant here is positive, so it would be we would be able to solve this, but the solution is a fraction and quite not as simple. We won't be able to factorize it using just factorization, except if we use the quadratic equation to find a solution. That will, let's leave it at that. Okay. Good, so the next question is solve the equation 3x squared plus 2x negative 7 equals 0. Show all your working and give your answers correct to 2 decimal places. So here we definitely have to use the quadratic equation. So that's x equals negative b plus or minus the square root of b squared negative 4ac all over 2a. Okay, then we just fill in the values. Let me just turn here. Okay, that would be x equals negative, fill it in 2 plus or minus, okay, negative, positive 2, sorry, squared, negative 4a is 3, c is negative 7. That would give us a positive discriminant. Here the inside there is called the discriminant, and we can get the solutions x equals something or x equals something. Let me just tap it into my calculator. Okay, that would give me 1.23 to 2 decimal places, because that's what they asked. It must be corrected 2 dp, 2 decimal places, and x equals negative 1.896. Okay, that would give me negative 1.90. So those would be the 2 solutions that I'm looking at. Okay, good. Let's turn the page. We're moving on at a nice pace, so just keep up. In this part, all lengths are in centimeters. The trapezium have an area of 15 centimeters squared. Show that 2x squared plus 5x minus 12 equals 0. Okay, so I know the formula for the trapezium. The area of the trapezium is a half base 1 plus base 2 times my perpendicular height. Okay, and I have a perpendicular height here. My base 1 is the 3x plus 2, and my base 2 is x plus 4. Okay, so let's go do that, and that I know would be equal to 15 centimeters squared. So 15 equals a half 3x plus 2 plus x plus 4 times my perpendicular height, x plus 1. Okay, now we just have to solve this. A half 3x plus x would give me 4x. That would give me plus 6. X plus 1, distribute. So a half 4x times x would give me 4x squared plus 4x plus 6x plus 6. And we just simplify this as 4x squared plus 10x plus 6. Distribute with a half, that 15 equals 12. Distribution there. 2x squared plus 5x plus 3. And that would give me 2x squared plus 5x minus 12 equals 0. And we are done with that one. Okay, so the next question asked us to to solve this. We will be able to solve this. So this is 2x squared plus 5x negative 12 equals 0. And I'm just going to do the factorization. Just use a little method there to help me. Negative 12 plus 5x, so 2x and x. Now, what would be the factors there of 12? That would give me negative 12, that would give me a positive 5. I think it would be 3 and 4. That would give me 3x. That would give me 8x. Yes, awesome. That works very nicely. And that would give me a negative. So if I cross multiply, x times negative 3 is negative 3x. And 2x times 4 would give me 8x. And that would be a factor. And that would be a factor. So 2x negative 3 and x plus 4. And that would be the solutions. Okay, equals 0. So I factored, and then from the factorization I can find the solution. So 2x equals 3, or x equals negative 4. So x would be 3 over 2, or 1.5, and x would be negative 4, and that's the solutions. Okay. Now they ask us to find the length of AB. Now AB equals 3x plus 2. So I've already found those values of x. Can a length be a negative number? No. So I'm going to use a positive number. Okay, if I measure something from here to there, or from there to there, it will still stay a positive number. It doesn't all of a sudden become negative because I'm changing the direction from where I'm starting. Okay, so therefore this negative 4 won't be a solution for a length. And I just do the substitution there. And if I substitute correctly, I will get 6.5. Okay. So let me just fill in these answers in their right spaces. Okay, good. We're starting at question 5. Question 5 gives us a triangle with some lengths and an angle. Show that the area of triangle XYZ is 38.1 centimeters squared, correct to one decimal place. So if I know that the area of any triangle is a half BC sine A. So a half B, we can just do it 5.4, C as 16, sine of 62 degrees. I tap that into my calculator, I get 38.1 centimeters squared. Okay. The next one is calculate the value of x. Now, if you look at this, well, we've got two options. I've got the sine rule and I've got the cosine rule. I don't have enough of our cosine rule because opposite the angle that I want, I needed length. And if I use this one, I've got a length there, but I don't have an angle. Okay, so let's use the sine rule. Sine A over A equals sine B over B. But let us find this angle, and I'm just going to call it Y, because then I have enough information. The sine of 48 over 8.4 and the sine of y over 6.7. Then I also know that the interior angles of a triangle add up to 180 degrees, and then I can find x. Okay, so sine of 48 over 8.4 equals sine y over 6.7. Okay, sine y would be 6.7 times sine 48 over 8.4. I find the inverse of that function, so and then I get y equals 36.4 degrees. Okay. Now let me just move it a little bit there. Use the space over there. Okay. I want the x now. I don't want the y, so I know that 48 plus x plus 36.4 degrees equals 180. I can solve for x. x would be 180 minus 48 minus 36.4, and I get 95.6 degrees. And that is my answer. 95.6 degrees. Okay, good. Question 5C. Here I have a bearing question. Ship A is 180 kilometers from the port A. So I'm just going to fill in those values. Ship B is 245. So 245 kilometers with a bearing of that. So that is 63 degrees. And that would be 146. So 146. Okay, degrees. Let me just write the kilometers in there. Okay, good. So now they ask us to calculate the distance between the two ships, between A and B. Well, if I have this angle, I can use my cosine rule. And that would be wonderful, okay? So I know that this bearing is 146 degrees, that one is 63. So I can just subtract the two from one another and find this angle. And if I do that, I get 83 degrees. So this angle here is 83 degrees, that one, okay? Good. Let's use a cosine rule then. So my cosine rule says a squared equals b squared plus c squared minus, look at me now, equal minus 2bc cos a. Okay, a squared is the distance that I want to find. B squared 180 plus c squared 245 squared minus 2 180 245 cos of 83 degrees. Okay, a squared. When I do that, I just plug this whole thing in my calculator. Okay, quickly do it. 81676. Okay, and that would be kilometers. But that's a squared, so I still want just a, and I get 285.79, or a is 286 kilometers. And I've rounded up to the nearest kilometer. That would give me 3 significant figures in any case, and all the other numbers, that's 3 significant figures, 3 significant, 3 significant, so I'm happy with that. 286 kilometers. And it makes sense. It can't be much more than that. Okay, in this question, write any probability as a fraction. Okay, Navpreet has 15 cards with a shape drawn on each card. 5 cards have a square, 6 cards have a triangle, and 4 cards have a circle drawn onto them. Okay, so let me get another clean sheet of paper that I probably need to just do that. Okay, sorry, just out of reach. Okay, good. So she's got 15 cards. Okay. 5 cards have a square, so it is 5 out of 15. 6 cards have a triangle, so it's 6 out of 15. And 4 cards is a circle, so it's 4 out of 15 is a circle. Okay, so that's that first bit. Navpreet selects a card at random. Write down the probability that the card has a circle on them. So we've done the work. 4 out of 15. Okay. Navpreet selects a card at random and replaces it. She does this 300 times. Wow, that's quite a lot. calculate the number of times she expects to select a card of a circle drawn onto it. So that would just be 300 times the 4 out of 15. So 300 times 4 out of 15. And if I do that, I get 80. So it's probably about 80 cards. Okay. Nafpreet selects a card at random, replaces it, and then selects another card. So she selects a card, puts it back, and then selects another card. Find the probability that one card has a square drawn on it and the other card has a circle. So it would be the probability of a square times the circle. Okay, so the square, the probability to get a square is 5 out of 15. Times to get the circle is 4 out of 15. And if I do the calculation, I get, what is 15 times 15? Let me quickly do that. 15 times 15, 225. And 20 out of 225. Another equivalent fraction would be 4 out of 45. That would be also considered correct. Okay, because all these need to be written as a fraction. Neither card has a circle on it. Okay, so it can't. Neither of the cards can have a circle. So we have square, 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 triangle. Okay, so she replaces it. So maybe we should just quickly do that. Square, triangle, circle, square, triangle, circle, square, triangle, circle. Okay, neither of the cards have a circle drawn on it. So square, 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 triangle. So the probability of a square times a square plus the probability of a square times a triangle plus the triangle square, triangle times square, plus the probability of getting the triangle, triangle. Okay, and the rest all have square circles in them. If I select the last leg, the circle leg, I will have a circle in them at least one. Okay, so now we just have to find those values. And that is 15 times 15. That would give me, that's 5 over 15 times 5 over 15. And that would give me 25 over 225 plus square triangle. That's 5 over 15 times 6 over 15. That would give me 50 over 225 plus 6 over 15 times 5 over 15, that would give me 30 over 225 plus triangle and triangle, that is 6 over 15 plus times 6 over 15, so 36 over 225. I do the calculation, I add them all up, I get 121 over 225. Okay, and that would be the answer. Okay, so Nafpreet selects 2 cards at random without replacing it. So here she does not replace the card, so it will change the values. So if I select, so that's my first draw, and the second draw, she doesn't replace the card, she leaves it on the pile next to her. So 4 over 15, sorry, that will stay, 14, eh? Okay, 6 over 14, 4 over 14, that would be 5 over 14, 5 over 14, 4 over 14, so that would give me 5 over 14, 6 over 14, and 3 over 14. Okay, so there's the Venn diagram that I will use. Okay, so calculate the probability that only one card has a triangle drawn on it. So we only want the probabilities that one card has a triangle. So it would be that one triangle, one triangle, one triangle, and one triangle. So I'm only looking at those options. A square times a triangle times a square, a triangle times a circle, and a circle times a triangle. That's the only 4 that will have only one triangle onto it. Let's quickly write it down. Okay, let me keep my little page here so that I can see what I'm doing. And so I'm just going to write down the probability of a square times a triangle plus the probability of a triangle times a square plus the probability of a triangle times a circle plus the probability of a circle times a triangle. Okay, and I find the values, the relative values, and we are right. So 5 and times 6 will give me, let me write it down, 30 over, and 15 times 14 is 210. Okay, plus a triangle is 6 over 15 times 5, 6 times 5 is 30 over 210, plus triangle is 6 over 15 times 4 over 14, that would be 24 over 210, plus circle is 4 and triangle is 6, so 24 over 210, and I can do the calculation, and that would give me 108 over 210, an equivalent fraction 18 over 35. Okay, the two cards have different shapes drawn on them, so none of them must be square, square, triangle, triangle, and circle, circle. So we can do it in both ways. I can say it is 1 minus the probability of getting a square times a square, plus the probability of getting a triangle times a triangle, plus the probability of getting a circle times a circle. Okay, and I've done this a little bit ago, so I'm just going to write down the values there. 210, that would be 20 plus 30 plus 12, and that would give me 74 over 105. Okay, good. So question 6 are done. Well, I think so. Let's just turn the page. Yes, we're looking at question 7 now. Okay, question 7, we have a grid and some flags on it, and it's probably a matrix question. So the first one is, they asked us, what would happen, what is a single transformation that maps A onto flag B? So A is over there and B is over here, and we can see that it's a rotation, and we can see it's an anti-clockwise rotation of, sorry, I should have said of 90 degrees, anti-clockwise around the point 0, 0. Okay, good. Then the next one is, what happens to A to get A onto flag C? Okay, I can see that it's an enlargement, but where's the center of enlargement, and by what scale factor? Okay, maybe it's easy for you to see it's a scale factor of 2 because my flag was 1 by 1 block and now my block is 2 by 2, and that would give you 2 marks at least. And what would be the center? So I'm just going to draw or use that very easy technique in connecting the vertices from the one shape to the vertex of the other shape to find the center from where the transformation took place. Okay, and there we go. So negative 2, 1. So I have an enlargement of a scale factor of negative 2, and it's around the point negative 2 and 1. Okay, good. So now they ask us, draw the image of a flag A after the translation by a vector 2 and 1. So it is A, and I want to move it 2 in the X and 1 in the Y. So 1, 2, and 1 in the Y, so my point would be there. And there is my thingy, and I'm just going to write a little B in here to say it is question B. Okay, we've done that one. C, draw the image of a flag A after a reflection in the line X equals 1. So X is here, X equals 1, that's the line. So that's my line, X equals 1. And I want the reflection in it 1, 2, 3, 4, 5, 6 spaces. So 1, 2, 3, 4, 5, 6 spaces. And there we go. We just draw our image equidistant from our line. And that was number C. Okay, good. Describe the single transformation that represented this matrix 1, 0, 0, negative 1. I'm just going to use my paper. So we want to know what would this transformation be. So I'm going to start off with my unit matrix 1, 0, 0, 1, 1, 0, 0, 1. Then I'm going to see what happens to these values when my new matrix is written. So 1, 0, and that is 0, negative 1. So what happened in the X direction, it didn't change, but in the Y, it was reflected around the X axis. Okay, can you see that this point is now there? It was reflected around the X axis. So my single transformation that maps it is a reflection around the X axis. Okay, good. So the last, we've got a few more questions. I think 2 more questions. Okay,